Okay, so now to solving simultaneous equations using the method of elimination. But first, a couple of reminders. The number before the variable in a term is called the coefficient. So in the term 6x, for example, the 6 is the coefficient of x. Now we should be using that word quite a bit in these movies. Secondly, just a reminder that when you multiply a term in an equation by a number, you must remember to multiply every single term in that equation by the same number, and that's on both sides of the equal sign, so do be careful about that. And thirdly, surprising as it may seem, we can actually add or subtract equations. We can add the left side of one equation to the left side of another, and the right side of the first equation to the right side of the second, and the new equation will still be true. Now I haven't got time to go into all the details of why that is the case if it's not obvious to you, but please take my word for it because it's a very useful idea. Let's begin with these two equations. 6x plus 3y equals 27 and 8x plus 2y equals 34. We start by numbering the equations. Call the first equation 1 and the second 2. The way this method works is to multiply the first equation throughout by one number and the second equation throughout by a different number so that the coefficients of one of the variables becomes the same in both equations. We could, for example, multiply the first equation by 2 to make the y term 6y and the second equation by 3 to make the y term 6y also. Or we could multiply the first equation by 4 to make the x term 24x and the second equation by 3 to make the x term 24x as well. There's not much in it really, so let's make the y coefficients the same as the numbers are smaller. Now we tell the examiner what we're doing by writing equation 1 times 2, and that gives us 12x plus 6y equals 54, and we number this equation 3. Then equation 2 multiplied by 3 gives 24x plus 6y equals 102, and we label this equation 4. Remember to multiply every term in the first equation by 2 and every term in the second equation by 3. Now the coefficients of y in both equation 3 and equation 4 are the same, that is 6. So now we can subtract the two equations, but should we subtract equation 3 from equation 4, or should we subtract equation 4 from equation 3? Well, we notice that if we subtract equation 4 from equation 3, we will get negative 12x, and that involves a negative coefficient, which is harder to deal with. So we'll subtract equation 3 from equation 4. Tell the examiner what we're doing by writing equation 4 subtract equation 3, and this gives 12x equals 48 as the y terms disappear. 6y subtract 6y is 0, of course. Now, isn't that a lot simpler? And from this we can deduce that x equals 4. Well, that's half the problem done. We know x, but we still need to find the value of y. Now, if we were really daft, we could do the whole thing all over again and eliminate the x terms to get the value of y. But as it happens, there's a much easier method. Simply substitute the value of x we've calculated back into one of the equations to find the value of y. Any of the equations will do the trick, so we'll obviously choose the easiest one we can find. And equation 2 looks pretty easy, so let's put x is 4 into this. We write substitute in equation 2, 8 multiplied by 4 plus 2y equals 34, i.e. 32 plus 2y equals 34. Subtract 32 from both sides gives 2y equals 2, and that gives us y is 1. So the solution to the equations is x equals 4, y equals 1, and that's it. Well, that's the basic method, but there are a couple of variations. Firstly, we subtracted the two equations because the coefficients of y were both positive. If one had been positive and one negative, we would have added the equations. So let's see that working. Here we have two new equations. 10v subtract 2w is 12.2, which we label equation 1. and 3v plus 9w equals 45.9, which we label equation 2. We decided to make the coefficients of w the same. To do this, we multiply equation 1 by 9 to get 90v subtract 18w equals 109.8, and we'll label that equation 3. Now multiply equation 2 by 2 to get 6v plus 18w equals 91.8, and label that equation 4. Now, when we say make the coefficients of one of the variables the same, it's okay if one of them is positive and the other is negative, provided they're numerically the same as they are here. As one is positive and the other is negative, we add the equations to eliminate the w term, and that leaves us with 96v equals 201.6. Dividing both sides by 96 gives v equals 2.1. Again, we substitute this into the easiest equation we can find, and that seems to be equation 1. So that gives us 10 multiplied by 2.1, subtract 2w equals 12.2. Now 10 multiplied by 2.1 is 21, of course, so 21 subtract 2w is 12.2. Add 2w to both sides gives 21 equals 12.2 plus 2w. Subtract 12.2 from both sides gives 8.8 equals 2w, from which we deduce that w equals 4.4. So there's our answer. W is 4.4 and v is 2.1. So, in summary, when you have made the coefficients of one of the variables in both equations the same by multiplying throughout, subtract the equations if the signs of the coefficients are the same, and add them if the signs of the coefficients are different. Now, there's another variation that can occur, and this actually makes the solution a little easier. Look at these two equations. 6m plus 4n equals 38. Label this equation 1. 3m subtract 3n equals negative 28.5. Label this equation 2. We can immediately see that the coefficient of the m term in the first equation is exactly twice that of the m term in the second equation. This means that we don't need to multiply both equations throughout by a number. Just multiplying the second equation by 2 will do the trick, and that'll save us a bit of work. So equation 1 stays as it is. 6m plus 4n equals 38. Label this equation 3. Multiplying equation 2 throughout by 2 gives 6m subtract 6n equals negative 57. And we'll label this equation 4. Now the 6m terms in both equations are positive, so we'll subtract the equations. I'm going to take equation 4 from equation 3, and this leaves us with 10n equals 95. And you must be very careful with those negatives here. And that, of course, gives us n equals 9.5. We substitute this back into equation 1 to get 6m plus 4 times 9.5 equals 38. Simplifying gives 6m plus 38 equals 38. So 6m equals 0 and m must be 0. So our solutions are m equals 0 and n equals 9.5. Now, just one small technicality. I labelled equation 3 as 3, even though it's exactly the same as equation 1. I find it easier to follow through the sequence of operations by doing this. Some people are really fussy and say if the equation is in the same form, it should have the same number. All I can say is don't lose any sleep over it. We could argue the toss all night and get nowhere.